Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in algebra. Its title, exponential function and logarithm function. What is the meaning of exponential function and logarithm function? Dear student, look at introduction about exponential function. أعزائي طلبة وطلبات شهادة الثانوية العامة، أهلا بكم. اليوم سنتطرق إلى درس جديد في الجبر اسمه الدالة الأسية والدالة اللوغاريتمية. طبعا هناك عدد جديد أول مرة نعرفه السنة دي اللي هو العدد إي، وهنعرف إن العدد إي في علاقة بينه وبين الدالة الأسية والدالة اللوغاريتمية. طبعا احنا عارفين إن في علاقة عكسية بين الدالة الأسية والدالة اللوغاريتمية. الدالة الأسية هي عكس الدالة اللوغاريتمية. اما تيجي ترسم الدالة الأسية وترسم الدالة اللوغاريتمية هتلاقيهم انترسكت، بيتقابلوا في ان بوينت، ولكن بيكونوا ريفليكشن فايس فيرسا. Dear student, look at introduction about logarithm function. Dear student, note that look at the curve represent exponential function. Exponential function, the curve intersect y-axis at point 0, 1. Remember, this curve represent function f of x equals a power x. X belongs to real number and a belongs to r positive negative 1. The curve passes through the point 0, 1, 1a, negative 1, 1 over a. Dear student, the curve pass through point 0, 1, look at on y-axis, 1a on x-axis, negative 1 and 1 over a. The number e, dear student, is definition by limit when x tends to infinity, 1 plus 1 over x inside bracket for all power x. Remember, dear student, the number e is limit when x tends to infinity. Bracket contains 1 plus 1 over x for all power x. Then when we find any limit when x tends to infinity, bracket 1 plus 1 over x for all power x is the number e. Remark, len 1 equals 2.718281828 by using calculator. The number e is limit when x tends to 0, 1 plus x for all 1 over x. The second form of the number e, limit when x tends to 0, bracket contains 1 plus x for all 1 power x. Example. Dear student, by using the previous, find limit when x tends to infinity, bracket contains 1 plus 1 over x for all power 3x. Another example, find limit when x tends to infinity, bracket contains 1 plus 1 over x for all power 3 plus x. Solution. Remember, dear student, limit when x tends to infinity, bracket contains 1 plus 1 over x for all power 3x equals what? Excellent student. We distribute the power about 2 as the example. Limit when x tends to infinity, bracket contains 1 plus 1 over x for all power x for all power 3. Why? Because 3 times x equals 3x. We distributed power 3x, 2 power x for all power 3. Remember, what is the limit when x tends to infinity? 1 plus 1 over x for all power x. Excellent student, is e. Then answer is e power 3. Another solution. When we find limit x tends to infinity, bracket contains 1 plus 1 over x for all power 3 plus x. What did you? Excellent student. We distribute the power bracket power 3 times bracket power x. Excellent student. Then the limit when x tends to infinity, 1 plus 1 over x inside bracket for all power x times what? Excellent student. Limit when x tends to infinity, bracket contains 1 plus 1 over x for all power 3. What do you mean limit x to infinity 1 plus 1 over x for all power x? Good, is e. Then the first limit is e, second limit is 1. Answer is e power x. Why 1? In the second year, limit when x tends to infinity 1 plus 1 over x for all power 3 by substitution about x equal infinity, then 1 over infinity is 0 equals 0. Then 1 plus 0 0, 1 plus 0 1, 1 power 3 equals 1. The first limit is e power x, but the second limit is e power x. Look at the student, we can try the solution. The first solution is limit when x tends to infinity, bracket contains 1 plus 1 over x for all power fifth x. Second, when limit x to infinity 1 plus 1 over x for all power 2x plus 5. Third, limit when x to infinity 1. Look at the first, when we distributed fifth x, we distribute the first bracket power x for all power fifths. What is the limit when x tends to infinity? 1 plus 1 over x for x is e. What is the value of e power fifths? Is e power fifths. Then answer is e power fifth. The second limit when x tends to infinity, 1 plus 1 over x for all power x for all power 2. The first limit is e. Answer is e power 2. Dear student, remember from the previous example, we prepare when x tends to infinity, 1 plus 1 over x for all power x, what you mean is e. Then when we find limit x tends to infinity, bracket 1 plus 1 over x power x, this limit must be equal e. After that, we distributed the power about 2 powers. 3, if the power 3x, we distribute power 3 for all power x. And substitution about limit equal e, answer is e power the value. Dear student, look at the example. Look at, dear student, the important example when find limit when x tends to infinity 1 plus 5 over x for all power x. Number 2, limit when x tends to infinity x plus 2 over x minus 1 for all power x plus 5. Remember, dear student, we want to find two limits. The first, limit when x tends to infinity, bracket contains 1 plus 5 over x for all power x. Second limit, when x tends to infinity, fraction contains x plus 2 in numerator, x minus 1 in denominator for all power x plus 5. Look at the solution. Remember, dear student, when we find limit when x tends to infinity, bracket contains 1 plus a over x for all power x is e power a. Why? Because, dear student, in definition of the number e is limit when x to infinity 1 plus 1 over x for all power x, but in this case the constant is a. Then answer is e power a. Limit when x tends to infinity 1 plus 5 over x for all power x equals what? Let, dear student, y equal 5 over x. Then in this case x not equal 0. Why? Because it's undefined. When y equals 5 over x equal 5 over y, what is the value? x, when x tends to infinity, y, x and student tends to 0. Why? Because 5 over 0 is infinity. When x tends to infinity, must be y equals 0 or tends to 0. Then we put the limit when x to infinity, bracket contains 1 plus 5 over x for all power x, as limit y equals 0, y tends to 0, 1 plus y for all power 5 over y. Why? Because we substitution about 5 over x is y and x is 5 over y. Then answer is limit when y tends to 0, 1 plus y for all power 1 over y for all power 5. Then answer is e power 5. The second solution, when we find the limit when x tends to infinity, bracket contains fraction, the numerator is x plus 2, denominator is x minus 1 for all power x plus 4. By distributed, when look at dear student, in numerator x plus 2, in denominator x minus 1, we can put 2 as negative 1 plus 3. Why? Because negative 1 plus 3 equals 2. In this example, we put positive 2 as negative 1 plus 3 over x minus 1 for all x plus 4. We distributed the fraction. Limit when x tends to infinity, x minus 1 over x minus 1 plus 3 over x minus 1 for all x plus 4. Then answer is limit when x to infinity, bracket contains 1 plus 3 over x minus 1 for all x minus 1 times limit when x to infinity 1 plus 3 over x minus 1 for all power 5. The first is e power 3, second is 1 power 5, answer is e power 3. Now we are translate to another example. Limit x to infinity, bracket contains 1 minus 1 over x for all power 2x. Another one, find the limit when x to infinity, x over 1 plus x for all power x. Limit x to infinity when 2x plus 5 over 2x minus 1 for all x plus 2. Solution. The first solution, when x into infinity, 1 minus 1 over x for all power 2x. We put 1 over x or negative 1 over x equal y. Therefore, x equals negative 1 over y. When x tends to infinity, x and student, y tends to 0. Why? Because negative 1 over 0 is infinity. After that, dear student, we put limit when x to infinity, 1 minus 1 over x for all power 2x equals limit y tends to 0, 1 plus y for all power 2 for all power negative 1 over y. Why? Because we substitution about x equals negative 1 over y. Limit when y tends to 0, 1 plus y inside bracket for all power negative 2 over y. Therefore, we put limit x tends to 0, 1 plus y for all 1 over y power negative 2. Remember, dear student, the inside bracket is e power negative 2. We substitution about limit when x tends to 0, 1 plus y for all 1 power y over y for all negative 2 is e power negative 2. Dear student, look at another example when we find limit x tends to infinity, x over 1 plus x for all power x. we distribute, look at the numerator x. We find x plus 1. If we add 1 and subtract 1 in numerator, example is true. Then we add positive and negative 1 in numerator to be the numerator 1 plus x minus 1. Look at limit when x tends to infinity. Bracket contains fraction. The numerator is 1 plus x negative 1 over 1 plus x for all power x. We distribute it about limit x tend to infinity. 1 plus x over 1 plus x equals 1. Negative 1 over 1 plus x for all power x. Remember, dear student, we divided the fraction into two fractions. The first fraction 1 plus x over 1 plus x is equals 1. The second is negative 1 over 1 plus x for all power x. Let y equals negative 1 over 1 plus x. Then 1 plus x by cross multiplication equals negative 1 over y. Then x equals negative 1 over y minus 1. When x tends to infinity, y tends to 0. Then limit x tends to infinity, bracket contains 1 minus 1 over 1 plus x for all power x equals limit when x tends to y, 1 plus y for all power negative 1 over y minus 1. We distributed it into limit when x tends to y, bracket contains 1 plus y for all 1 over y for all power negative 1. Remember, dear student, when limit x tends to y, bracket 1 plus y for all 1 over y equals what? X and student equals e. After that, we multiply the remainder limit when x tends to 1, x tends to y, 1 plus y for all power negative 1 equals e power negative 1 times 1 plus 0 for all negative 1. Answer is e power negative 1. Limit when x tends to infinity, 2x plus 5 over 2x minus 1 for all x plus 2. Dear student, what did you use? Yes, x and student. We convert 5 into negative 1 plus 6 as a solution. Look at 2x plus 5 becomes 2x minus 1 plus 6. Why? Because we distributed the fraction into two fractions. The first fraction 2x minus 1 over 2x minus 1. After that, we add the second fraction 6 over 2x minus 1. Each one power x plus 2. Then the fraction becomes limit when x to infinity. 2x minus 1 over 2x minus 1 is 1 plus 6 over 2x minus 1 for all power x plus 2. Remember, dear student, when y equals 6 over 2x minus 1 by cross multiplication, we deduce that 2x minus 1 equals 6 over y, 2x equals 6 over y plus 1, then x equals 6 over y divided plus 1 over 2. After that, when write limit x tends to infinity, bracket contains 1 plus 6 over 2x minus 1 for all power x plus 2 is limit y when y tends to 0, 1 plus 6 over y for all power 3y plus half. Therefore, we put the fraction as limit when y tends to 0, 1 plus 6 over y for all power 1 over y for all power 3. Then limit, we add the second limit when y tends to 0, 1 plus 6 over y for all power y equals what? 6 e power 6 power 3 is e power 18. Now we are translate to natural logarithm function. Look at, dear student, function when base is e is f of x ln x. Remember ln 10 by using calculator, start ln 10, we find 2.23 and so on. Some properties of natural logarithm. Dear student, some properties of natural logarithm very important. The first, when x belongs to r positive. What is the r positive? Is open interval from 0 to infinity. When y belongs to real numbers and a belongs to r positive except 1, then we find ln x equals y, equivalent e power y equals x. Remember, dear student, there is a relation between ln x equals y and e power y equals x. When we find the value of x, we find x equals e power y. What do you mean ln x equals y? Mean e power y equals x. Ln, remember, e power ln x equals x. Ln e equals 1. And ln 1 equals 0. Equal log x over log a as ln x over ln a. Ln x over y as the log ln x minus ln y. Ln xy equal ln x plus ln y. In case product of xy, ln of xy equal ln the first x plus ln of the second y. Ln x for all power n equals n ln x. Log x with log x e equals what? Equals 1 equals ln, when limit x tends to 0, a power x minus 1 over x equals ln a. Limit when x tends to 0, a power log 1 plus x over x equal a power log e. Limit x tends to 0, then 1 plus x over x equals 1. Limit n plus 1 minus limit ln n equals also 1. Example. Dear student, find limit when x tends to 0, 2 power x minus 1 over 3 power x. Number 2, limit when x tends to 1, ln x over x minus 1. Number 3, and when x tends to 0, ln 1 plus 2x inside bracket over x. Limit x tends to 0, a power 5x minus 1 over x. Look at the solution. Find limit when x tends to 0, 1 plus 3 cosine power 2 x for all power sec power 2 x. Limit x tends to 0, limit 1 plus 5x power 2 over 3x power 2. Look at the solution. At the first, limit when x tends to 0, 2 power x minus 1 over 3x is third multiply limit when x tends to 0, 2 power x minus 1 over x. Dear student, in this case, we are taking properties of ln. Ln xy means ln x over ln y. Ln x over base y equal ln x over ln y as the log. There is a relation between ln and log. Remember, dear student, the number e is limit when x tends to 0. Bracket contains 1 plus 1 over x for all power x. Dear student, look at the solution of this example. Limit x tends to 0, 2 power x minus 1 over 3 power x equal third. Why? Because 3 is constant. Limit when x tends to 0, 2 power x minus 1 over x equals what? look at limit when x tends to 0 2x minus 1 over x equals ln 2 equals third ln 2. Limit when x tends to 1 ln x over x minus 1, dear student, is limit when x tends to 1 ln x over x minus 1 equals 1. Limit x tends to 0 ln 1 plus 2x over x equals 2 over 2 ln x tends to 0 ln 1 plus 2x over x. Answer is half multiply 1 equals half. Limit x tends to 0 1 plus 3x 3 cosine power 2x for all sec square x is limit when x tends to 0 1 plus 3x power 2 x for all power 1 plus cosine power 2x. Answer is e power 3. X limit when x tends to 0 1 plus 5x power 2 over 3x power 2. Remember, dear student, we multiply 5 and divided 5. Look at the numerator, multiply by 5 and divided by 5. Then the fraction is 5 over 5 times limit when x tends to 0 1 plus 5x power 2 over 3x power 2. After that, answer is 5 over 3 limit x tends to 0 1 plus 5x power 2 over 5x power 2 when x tends to 0. Answer is 5 over 3 times 1 when limit x tends to 0 1 plus 5x power 2 over 5x is 1. Then answer is 5 over 3 times 1 is equals 5 over 3. Dear student, by the end of the lesson, we know that the relation between ln x and logarithm of x. And we know the relation between exponential function and logarithm function. Dear student, I am very happy to spend such time with you. Goodbye.